Thank you. I'm very pleased to be here. I'm very pleased also to give a talk for Professor Bass on the day of my birthday.
Happy birthday!
Well, I just maybe like to go back a little bit to diffusion models, because in fact it's very, very similar in spirit to what we've seen here, stochastic models and stochastic purchase timing. If you look at the Hayes, we cannot.
No, it's not. That's black wall.
Oh,
Pull the blackboard out.
No, that's a wall, right?
oh, yeah, because I saw people doing it here. This is a black wall. All right. No, that's all right. This with chalk. Okay. No, it's not.
Yeah, you can.
No, I saw people.
Yeah, you can.
That's why you got the white.
It looks like.
This is like
Right.
bring up the lights.
Oh.
So people can see.
I just wanted to. Sorry for the confusion. I gave a talk on confusion. Well, I think just want to show the relationship between diffusion models and the purchase timing models. The standard relationship here for diffusion model is this. And if you look at this, he says, well, there is a relationship between probability to buy and proportional buyers at time t. So there is contagion. This is very straightforward, naive, very simple, maybe wrong interpretation. So this is the Bass setting. If you look at the NBD, you have E of x2 given x1. x2 is the number of purchases in time period 2, given x1 purchases in time period 1, is equal to alpha plus beta x1. So it's a linear function of the number of purchases in period 1. So it looks like there is a relationship between the number of purchases in period 2 and the number of purchases in period 1. And in fact, it's the weighted average between the mean number of purchases across the population and the number of purchases of a randomly picked person. So it gives him feeling that there is a contagion, because the number of purchases of that person is a function of the purchases of all the others. So the naive person says, well, there is contagion, because it's a function of the overall number of purchases of the others. Contagion. Well, this is very naive, very simple. The beta binomial is exactly the same. E of x2 given x1, k is alpha plus beta x1 is equal to W. Okay, so weighted average of the overall probability of purchase and the number of purchases over k purchases of category last time. So all this shows that it looks like there is contagion, when in fact you can explain those relationships with a compound timing model. Right? So we are revisiting Bass' interpretation of the Bass model. So we do not agree with the Bass view of his own model. Abel Geland was the first one to realize this, and he included heterogeneity and reinterpreted the Bass model in this view, saying that what determines purchase is propensity to buy, and the others as to the extent they reduce risk. In this paper, I show that you can obtain the Bass model as a mixture model, assuming shifted Gompertz individual level model combined with exponential model, and you get Bass model. No contagion, no P, no Q. Of course, there are two parameters, but no contagion. In this setting, you can apply Eric Bradlow view, because you don't need a Q contagion. Right? So, this review the whole idea of contagion imitation, but still keep the core structure of the Bass model as a valued, a very rich structure to be kept as a treasure. Open issues in choice model. Well, one issue is the parameter is identification issue. Here's an illustration. Thank you. Here's an illustration. I think very little work has been done in marketing on identification of parameters. People have a lot of data, they estimate parameters, without much concern what do those numbers actually mean, are they identified. Here's an example. I have a sequence here of 0 and 1s. They are t equals 17. And if I use a Bergeland model, inertia model, you get two things for the same price. You have probability that xt is equal to 1. This is marginal probability. This is 0.81. And the inertia factor, which is 0.58. If you assume that the marginal probability is equal to 50%, say, well, I know this is 50%, so there's only one parameter left. You get inertia factor of 0.84. Inertia is the short-term tendency to repeat purchase. So you have a very different view. There is much stronger correlation if you assume that the marginal probability is known. Okay? Second, those are real sequences of 0 and 1, the real ones. I'll take another one. If I estimate the two parameters, I get 0.61 and a minus. So it's not inertia, it's variety seeking. Tendency to switch to the other alternative is minus 0.28. If I assume P of xt is equal to 1, 50%, I get zero inertia, is a zero order process. Third example, t equal 11. So I get 0.36, P of t equal 1, minus 0.58. This is the variety seeking. If I assume P of xt is equal to 1/2, I get minus 0.14. So you have two different views of the same sequence. It turns out that 1 is equal to a boy and 0 is a girl. Okay? So those are real sequences. I know people who have 16 brother and sister. Yes. With passports. It's not just talks, passports. So that's the variation of marginal probabilities. Makes sense to biologists. Would you accept that women have so different probabilities to have boys from 0.81 to 0.36? Would the biologist accept this? In marketing, we say, yes, probability to buy Coke, maybe 0.81. So we have no way to assess the plausibility of these estimates. Biologists maybe have a way. What I'm trying to get to is that can we infer both brand loyalty and short-term tendency to repeat purchase from a purchase sequence only? So we get both parameters for one sequence. Some people say, well, you need very long strings. If you get, but of course women are limited. So you need very long strings, maybe you get the good numbers. But how long should the string be? So what I'm trying to get at is more work should be done thinking rather than computing. Predicting the effect of out of stocks. Two models of choice capture out of stocks adequately. Out of stocks occur quite a bit, quite often, and they give a lot of information about interaction between brands, between products. Do elasticities change? Are their predictions consistent with the evidence? What are the potential effects on price elasticities? Third alternative, third issue, modeling choice in typical situation in the supermarket. Most choice models seem extremely stylized. They look very complicated, but in fact they are extremely stylized. Why? There are often more than 300 UPCs on the store shelf in certain product categories. More than 300. Sometimes 200. 250 is a typical number. How can choice be modeled in a pragmatic yet realistic fashion? How can aggregation take place in a realistic situation? How can we aggregate across brands, across price ranges? Those are some of the issues that people do think about. Who is it? Huh? Oh, it does say, oh, sorry. Why does he appear here? Why does he appear here?
They spend time in France.
5 years. This is the person, third president of the United States, that Professor Bass would have liked to meet. Thomas Jefferson. Maybe we'll explain to you why. Thank you.
Thomas Jefferson has a very good quote. He believes in luck, and he finds the harder he works, the luckier he gets. Very good.
We are here as a trio. Notice we have one speaker, and then it took 2 speakers, and now we're up to 3 speakers to fill half an hour. So if anyone has a question, an intellectual question in the area, we wanted to write something on a blackboard in the spirit of the seminar, you know, in sort of challenge. So that was Albert's task. Obviously, we failed. So if you'd like, we can move on to the next.
Stochastic, actually. It's very stochastic. The talk.
Random order.
Without much structure, too. You had the yelling part, too, because Peter yelled at you to get the hell off the stage.
I said, gee, I remember the slide, but I don't know what to say about it. Anyone? Okay, then I think we can move to the next segment if Bob and Leonard